Hello, and welcome to part 1 of what I've learned so far about event sourcing in a microservices environment. This presentation is most suitable for developers with design experience, particularly in microservice environments, or developers or architects who are interested in this area. When I started looking into communication between microservices and event sourcing, I found a lot of contradictory information and differing opinions. So this is a distillation of everything I've learnt from sources that I came to trust and subsequently put into practice to prove that it works. I've split the presentation into a 4-part series covering the basics of CQRS and event sourcing, then a common architecture and how to handle concurrency, and finally a demonstration of event sourcing in practice, plus a note on choreography versus orchestration. We've kept each presentation short. This one lasts about 5 minutes. Right, let's get started with the foundational principles. First up is CQRS, or Command and Query Responsibility Separation. The most common way to interact with a repository is as a CRUD store. The same domain classes are used between read and write, or command and query, and often between multiple architectural layers. This is often fine and exactly what we need, but sometimes needs become more complex. For example, we may want to fold multiple records into one for presentation to the user. Or, on the right side, we may want to process the data we receive and store our conclusions, rather than receive data itself. As this occurs, we begin to see multiple representations of the information, but still being resolved down to a single conceptual representation of the repository. As complexity increases, having a single representation of the data leads to a complex model that serves no one particularly well. Enter CQRS. CQRS splits the conceptual model into separate models for update and display, or command and query. For example, on a web page, the view will be rendered using the query model, and the change will be routed to the separate command model. Then the resulting change is communicated to the query model to render the updated state. Now, rather than just having one model shared for all reads and writes, we can have multiple specific write models and multiple specific read models, each one separate to the service that requires it. CQRS models may share the same database, in which case the database acts as communication between the two models. But often, the read and write sides use separate databases, particularly when there are different performance requirements for read and write. For example, if we consider a video streaming service, the write and read performance requirements may be very different. An internal user may write a video to a repository, and that could take half an hour, and it can be prone to failure, but it doesn't matter, because the customer doesn't see it. However, that video might be watched by tens of thousands of people at the same time. Because the write and read are split, they can be deployed to different hardware and scaled differently. In this case, there needs to be some communication mechanism between the two models. But now we have to compensate for the fact that our system becomes eventually consistent. For example, video recommendations should only recommend videos that are available on all read servers. This compensation for eventual consistency often causes extra development effort, and is a significant mental leap from simple CRUD to CQRS, so CQRS needs to be worth it, and it should be applied to the correct problem. As we said, it's applicable to systems where performance needs to be scaled differently for read and write, and it's also applicable in event-based systems. So here's a couple of common questions that we've received about CQRS. The first one, can command and query share the same database? Yes. It does often make sense for read and write to have their own databases, particularly if they're split as for performance reasons, and the read side will benefit from having its own copy of the data, and so it can scale its data store with itself. But equally, a single highly performant database or a cluster could support the write and the read side. For example, reading might be an uncommon operation, and so to save computing resource on the cloud, the read side may only spin up when required. Don't get too tied up by dogma. If it seems sensible in your context, it probably is. And the second question, do I have to be doing microservices to use CQRS? Microservices can mean many things to many people, but let's just consider it to be a collection of services. But CQRS doesn't imply microservices, or any architecture apart from having separate read and write routes. It can be as simple as having one database and two applications interacting with that database, or it can be multiple databases with writes being projected to hundreds of different read databases via queues, or it might involve no databases at all. It really just defines that the responsibility for command and query, or read and write, are separated. Having said that, microservices are often implemented to achieve fine-grained scalability, and CQRS is often applicable in such scenarios. If you have any questions about the short video, please feel free to email me directly or get in touch with us via one of the below links. As we said, CQRS often makes sense in event-based systems, which leads us nicely onto part 2, event sourcing. Thank you for watching part 1. I hope you continue to part 2.